Welcome to ClueCon Weekly. Join us every Wednesday to learn about the latest cutting-edge developments in the real-time communications industry. ClueCon Weekly is brought to you by FreeSwitch Solutions. Get support and professional services directly from the creators of the FreeSwitch open source project, solving your issues in the most efficient, stable, and scalable way possible. Get the FreeSwitch advantage. Visit freeswitch.com. Also brought to you by ClueCon, the premier technology conference for developers by developers. Join us every summer in Chicago. ClueCon kicks off on Monday with our annual hackathon, The Coder Games, followed by 3 days of technology-rich presentations discussing telecom, WebRTC, and IoT from developers around the world. To learn more, visit ClueCon.com or call 877-74-A-CLUE.
And welcome to ClueCon Weekly. Today is the 20th of February, 2019, and this week we're going to be joined by Ritesh Mukherjee from 128 Technology. So he's going to be showing off some cool stuff that they're working on with some routing and that kind of fun stuff. So stand by for that. First, let's go over and see Miss Abby for the news. Abby, how are you doing today?
Hi, everyone. I am doing great today. Thank you for asking. And as always, thank you so much for joining us today on ClueCon Weekly. If you have any questions at all during this call, feel free to ask us in the IRC or Slack channels or the HipChat channels, and we will do our very best to answer them live during this call. A big announcement is that our next online FreeSwitch training is on March 14th. You can sign up for that on our website if you're interested in FreeSwitch training. And of course, save the date for ClueCon. It's coming up way quicker than you think. That's August 5th through 8th, so we're back to our normal dates. So save that date in your calendar. And our call for speakers is officially open. So if you are interested in speaking at ClueCon, you have about 2 months to get that submitted. And we really want to hear your talk, so don't forget about that. Don't forget to submit. Sooner is always better than later. Also, this year, we are offering a new kind of registration, which is a Coder Games only registration. So if you or somebody that you know in the area is interested in only going to the Monday Coder Games, they can do that for $99 on the registration page. But of course, if you are registering for all of ClueCon, that ticket is included in your registration. But if you know somebody who is interested in only showing up on Monday, there is now a ticket just for that. Also, thank you to SignalWire. We have a brand new SignalWire code for you guys to use for when you sign up in order to get $50 in credit. So you can use the code CCWeekly19 for $50 in credit when you sign up on our website, signalwire.com. So I will put that code in the YouTube comments right after I'm done with these announcements. And if you are not familiar with SignalWire yet, they are the primary sponsor of the FreeSwitch open source project, and they unlock all of the features of FreeSwitch through easy-to-use APIs. So you should definitely check it out. We're giving $50 in credit to go play around with it, so I definitely recommend that you do that. Again, I'll put the code in the comments right after this call. All right, that's all the announcements I have for today. Back to you, Ken.
All right, thank you very much. Thank you very much, Miss Abby. Oh, how about I hit the right button here somewhere? All right, guys. Hey, we're going to jump over to Mr. Michael Malvarudis. I think he's got Mr. Jarris joining him for Community Corner today. Hey, guys, how y'all doing?
I'm doing okay.
But the knowledge is all solid in there. That's what it comes down to, right? So today's question comes from Adrian. So Adrian asks, hi, I've developed a couple of endpoints and I use BG API to originate and bridge. FreeSwitch intercepts and interprets DTMF, and I do not want that. In the dial plan, I tried parameter name pass RFC 2833 equals true. And also application set pass RFC 2833 equals true. Action application set execute after bridge app stop DTMF. Action application stop DTMF. Action application span DSP stop DTMF. None of those methods work. Maybe there is a parameter in originate that I should use. So Mike, what's going on here?
Okay, so some layers in this. We're talking about their own endpoint. It appears to be an RTP-based endpoint from what I guess out of that those details. So first question is, does that endpoint implement any of its own native DTMF handling? If it's not an RTP endpoint, the pass-RFC 2833 param is a Sophia specific configuration param, so that's not going to do anything in your own endpoint unless you've designed it to do something. The channel variable pass underscore 2833, if it's an RTP endpoint, based endpoint, it's using our RTP stack, would do something to make those DTMF ignored. So if none of those are doing anything, my guess would have to be that this either isn't an RTP-based endpoint or that it's using its own RTP stack of some sort, and the answer lies somewhere in your own code. Everywhere that we implement TTMF handling and free switch, we don't do anything to like automatically handle in-band DTMF outside of the hardware endpoint, free TDM. So nothing to do with us stopping the DTMF detectors would make any difference here. So my guess is the answer lies in your own code and how you're handling DTMF. The past 2833 parameters only happen with our own RTP stack. So hopefully that clarifies a little bit where that handling's taken care of. And helps.
And so what should he start doing? Start looking at PCAPs and stuff like that?
I mean, we don't know a whole lot about his endpoint, what he actually wrote from here, but my guess is that this is a custom endpoint that implements its own media altogether. If it's actually using our RTP stack, say like Modverto does, then the pass underscore 2833 channel variable would work. So the fact that that's not working tells me that he's not using our RTP stack at all. And if that's the case, it would all be in their code as far as figuring out how to actually handle that.
All right, cool. Thank you, Michael. Answers from the experts.
No problem.
Feel better too.
All right.
So back to you, Ken.
All right, let's just jump over to Miss Abby for Blogspot.
All right. Hi, everybody. So last week for the blog, I wrote a little bit about our ClueCon 10-year challenge. And if some of you are not familiar with the 10-year challenge, it's just a silly little internet craze where people will post a picture of themselves from 10 years ago and a picture of themselves from today. So I wrote a little bit about our 10-ish year challenge because ClueCon is actually going to be 15 years old today. So I thought it would just be a little bit of fun to talk about how ClueCon was 15 years ago and what it's going to be like this year. So the big question that we get a lot is, which came first, the chicken or the egg? No, which came first, ClueCon or FreeSwitch? So in this case, ClueCon came first. It actually started 1 year before FreeSwitch was publicly released. And ClueCon was founded way, way back in the good old days of 2005 from an aspiring team of Asterisk software developers who wanted to push the envelope, aka Brian West, Mike Jarris, and Anthony Minasali. So their quest was to gather all of the open source projects into one place because before ClueCon, there wasn't one conference, at least near where we are, that covered everything about open source telephony and all of the different projects in open source telephony. So they decided to create a place where people could come together and share everything that they were up to. So many people from around the world actually attended that first ClueCon, and they talked about everything from telephony and bouncing crazy ideas off of each other. So from these conversations, the team actually figured out what they needed to do in order to get FreeSwitch really going, and then it was finally presented to the public at the second annual ClueCon the next year. And that's when ClueCon really started rolling, and now we are at 15 years. But of course, everyone who's familiar with the 10-year challenge knows that it's not all about being perfect. It's all about how things change and grow. And it would definitely be a lie to say that everything about that first conference was completely perfect, but it did have a lot of character and that wonderful family atmosphere that we still hold on onto today in our ClueCons today. Of course, the team is full of developers. Nobody's organized a large event before, so there were a little bit of road bumps. In fact, some of you have heard this story before, but there was a police raid at the first hotel that they ever did ClueCon at. Of course, no one from ClueCon was arrested. It was a unrelated guest, but it still gave that first conference a little bit of excitement, didn't it? So we have definitely evolved in our ClueCon today, 15 years later, but we still carry that same character and that same sense of family with us today. And we are so excited to celebrate our 15th year. While we started our focus on open source telephony and VoIP 15 years ago, we've now evolved into adding things like RTC, IoT, Maker, SignalWire, and everything else that's cool about development into the discussion. And I'm sure we're going to add even more in years to come. Every year for 15 years, the same core members of the FreeSwitch team still produce and oversee the conference with the original goal in mind, which is to blend a diverse collection of open source projects, speakers, and technology presentations that continue to inspire the way forward. And a lot of people from a lot of different backgrounds come together to collaborate. We've created a space for developers to work through problems together and to share the projects that they're passionate about. So our attendees have told us many times before that going to ClueCon is kind of like taking a college course all in 1 week. You learn a lot during the day and you socialize a lot during the evenings. So a lot of people enjoy that. We've added this, not this year, we added a couple years ago our hackathon event that I talked about in our announcements earlier, the Coder Games. It challenges attendees to techie and not so techie games. And this year is going to be evolving even more. We're going to be building our own self-driving cars, and I've got a little bit of a game show cooking up here. So we're gonna see a lot of evolution in the Coder Games this year, which I think you guys will all enjoy. Of course, we don't put on this conference for ourselves. We do it for all of you. So feel free to let us know like what you would like to see done in the future, what you've liked in the past. You can let us know at our Slack channel at signalwire.community. We have a Slack channel dedicated to ClueCon to hear all of your thoughts about our conference. So that's all I have today. Do not forget to register for a speaking proposal if that is what you are interested in. And if you just want to attend, don't forget to register at ClueCon.com. And if you know anyone who just wants to go to the Coder Games, let them know that that is an option as well. So that is all I have for our blog spot today. I will see you guys next week. Thanks, guys.
All right, thank you, Miss Abby. And let's jump over to Mr. Mavrutis and Ritesh. Hey, Ritesh, how you guys doing today?
Hey,
Hi, Ritesh. Ritesh, what do you have for us today?
we're
Ritesh
going
is
to be
from
talking
128.
about yeah.
Oh,
So
sorry.
we are going to be talking about session-based routers today. The difference between traditional routers and us is that we make everything session-oriented. So we follow streams and flows and UDP flows, and we work on that. That reduces the bandwidth usage, enables fast failovers, and a lot of other cool stuff. I have a presentation for you guys. It's to go over the technology and what benefits we bring, and also to introduce the company.
Okay, so let's get started.
So we are 128 Technology. We are based in Boston. We are about 4 years old. We have about 100 people in the company. Most of our development is in Boston. Our sales teams are spread out across the globe. We make session-oriented routers. The difference between traditional routers and us is that we keep state per flow. And I'll come to what it means. If you look at legacy networks, how legacy a bit of that. You have routers which are stateful, which are stateless in the sense they don't keep any state for any flow. And then depending on what you want to do in your network, you add firewalls if you want to allow flows in one direction over the other. If you want to send loads to one site over the other, then you have load balancers. If you want to figure out what the packets are, you add some deep packet inspection. And obviously, if you want to send tunnels, if you want to send packets in pathways which they are not supposed to go, but take another pathway, then you create tunnels between them, and you use these tunnels to send packets. This is a very hardware-centric world in the sense it's a siloed environment. And there's a lot of different moving parts making networks complex. We also believe that it also hinders innovation in the sense, like you guys were speaking about, open source projects and so on. Now we have open source, and we ourselves use open source DPDK and other things, FRR, in our routing world. But if you have all these stateful devices doing different things in the networks, it makes it very difficult to really run networks the way we want them to be run.
So what's the advantage
is network should
of putting all these technologies together?
Sure. So the advantage of collapsing the different functions together is that you have lower costs. Now a single box is able to do different functions. You also reduce the complexity in the network because you don't have to make flows go in different directions through these different boxes. And mainly the real advantage is time savings and resource savings. You don't need CCIEs to configure networks as you had to do and invest in, a lot of resources. The way we look at networks is we look at everything as sessions, in the sense everything is a two-way communication between two parties on the internet, much like this call, where I am talking to some server and that server is talking to others and so on, and it's bringing everything together. It can also be a multi-point conversation like multicast, where we have some parties talking to many parties and so on. Any exchange in the internet, we view it as a session. For example, when I ask YouTube to send me packets and YouTube sends me packets, that's a two-way exchange between me and YouTube. And if YouTube sends me packets without me having asked for it, then it's an attack on me. So we learn many things through directions and through sessions. We believe that the networks only exist to deliver services, and the way we should configure networks is by services. So that's how we look at the world. And we have done mainly 4 major things to the router to make these changes, and I'm just going to go over them. So unlike traditional routers, we track flows per session. So when a packet comes into our router, and I'm going to do a walkthrough on the life of a packet, we learn many things from what the packet is, and we keep state per flow. So we don't have to encapsulate packets in tunnels or VPNs or IPsec tunnels or any other form of tunneling technology. We also learn many things from directionality and from who's sending to whom, and we can control the sessions better. The way we also configure networks is service-centric. If you ask a traditional networking person how they configure networks, they would say they need to have 10.10.10.10 talk to 20.20.20 and so on. Well, that's what the network needs to do, but that's not what the business logic demands. The business demands, for example, give access to Facebook or remove access from Salesforce, or give a particular marketing person access to Salesforce and so on. So what we do is we follow business logic to configure networks, and it's name-based. So you can identify applications and you just identify them by name. For example, you could say, give everybody in the company access to Gmail and so on. Waypoint settings. This tells us how to forward packets. So we forward packets from the interface address of IP address of a router to another. And we do NATs to control the path. By doing that, we remove the endpoints from participating in the middle of the network. And we are able to choose pathways which would meet those SLAs. For example, if there's a unified communication session, we would tell the network that keep it on a path which has a MOS score of at least 4.1 or anything else you could say. Or you could say put it on a path which has 100 millisecond latency. The routers we have, they monitor among themselves paths, and they can put it on paths which meet those SLAs. Of course, we need to establish a connection between the 2 points, and we do that by using an intelligent cookie or metadata that we send only in the first packet. By doing this, we remove the need for having tunnels and any sort of encapsulation technologies in the network. So we are able to send this intelligent cookie. The router on the other side, it gets this cookie, extracts it, figures out what to do with the packet, and sends the session out. Combination of these four things that we have done with the router makes it a very different than traditional networking. Now you're able to collapse functions, do service-centric networking, and also have all integrated functions in the network done by the router itself. You don't need separate WAN optimizers, load balancers, firewalls, and other things. You still have them in the network if you need to do some really specific or specialized functions, but most of the functions can be done at the routing layer, or the networking layer can be done by the router itself. This simplifies networks, reduces costs, and other benefits. Let's take a look at how we would actually do all of the things I said. Let's say you have packets you want to send over the internet or any network, and you have two of our routers in the middle. You want to send packets from the source to the destination. You send the packets out, the router receives the packet. When it receives the first packet, it knows that it matches it with the existing sessions it has, and it knows that this is a new session. Let's say there is an associated policy for it. If there is no policy, we would drop those packets, in the sense we are a deny by default router. We don't simply forward packets. We would first authenticate and then only trust. So you have to have a policy configured. We work like a firewall in that respect. So if there is a policy associated, that policy tells us what kind of QoS this packet needs, what kind of security it needs, and any other things, what kind of load balancing capabilities it's required, and so on. If we know it's a valid packet, what we would do is we would extract the source and destination IP addresses from the packet itself, put it in the metadata, put it as a metadata in the payload section of the packet, recalculate the checksums and everything else. This way we don't have to add a full IP header per packet if we were to send it. And then we do a NAT, network address translation. Basically, we do the NAT. Instead of sending it from source to destination, we send it from waypoint 1 to waypoint 2. That's how we control the path in the network, or the path these packets will take based on the SLA, the service demands. And then we send the packet. We can encrypt the packet, or follow in QoS or other things, and send the packet out. Once the packet hits the upstream router, it removes the metadata, and from there it knows what source and destination the original packet was supposed to be for, and it will do a NAT again to recalculate the packet, send it out to the destination. We only do this for the first packet, and after that everything is forwarded at line rate. Both the routers keep state, so they know what to do when any of the subsequent packets come in. The advantage of forwarding things this way is we control the path in the network. We know what the sessions are. We can collapse functions like load balancers, firewalls, WAN optimizers, whatever they do, we can do in the router itself. And also when these packets go through any network boundaries, they don't see any issues in the network, in the sense the end applications do not see any changes or any mistakes or any jitter, delay, loss in the packet stream itself, because the routers handle the different pathways and so on. All of our routers, you can have many different connections. You can have internet, MPLS, LTE, or any other different type of connections, and they can switch paths between these connections and keep the sessions alive as required. So if you were, let's say, having a call with another party on the internet, a Skype call, and it was going through our routers, the routers would monitor different pathways among themselves and keep the call on a path which meets the SLA you have set it for. It can also switch paths and without any failures without the endpoint seeing any degradation or failures in the network. How does a deployment scenario look like for us? You can host our since we only make software which runs on any Intel or any x86 hardware. It can run on any other hardware as well. We can also run on the Amazon Azure or Google Marketplace. We are available there. You can run us as an instance in any of those public clouds. You can run us in your private data centers. The advantage of doing this is, for example, let's say you have a deployment. You could have our routers in different parts of your network, and they would enable connectivity among multi-point connectivity among each other. The difference in traditional routers is if traditional routers were used to connect points like this in the network, you would have to build tunnels among them. And it's an n-square problem in the sense it's not possible to have, let's say, 5,000 sites. You can't have a 5,000 times 5,000 tunnel endpoints per router. In our case, you don't need to do that. It's on demand, it's a full mesh, and the router's established connections is needed. The conductor is basically a network management tool that we have, which uses our REST APIs and can talk to our routers. Having said that, we just to sum and give you the benefits of all these solutions before I go and show you the differences between traditional routers and us. We make software which runs on any x86 Intel hardware. We are service-based in the sense you configure things by words. It's location independent. We always forward packets towards services. So if you have new services which change locations, packets would get forwarded accordingly to those new services, and it's location independent. We are application aware. We can identify thousands of applications by the flows themselves. You can just set policies for them. For example, you can tell us send YouTube over this path versus my Skype business calls, and we would do that, and so on. We can detect applications on their own in the network. We do not use any tunnels in the sense we don't use encapsulate packets like traditional routers. We have complete segmentation. When you encapsulate packets, you put many flows in a single tunnel, and we don't do that. We don't aggregate flows like that. For us, every flow is a separate segment. We have dynamic slicing and network stretching. You can connect networks using our technology. We are a full layer 2 to layer 4 stateful firewall. We also have other IDS IPS capabilities. If you want to encrypt packets, you can, but if they are already encrypted using TLS or IPsec or any other technology, you don't have to re-encrypt the packets. We can detect encrypted packets on the fly and not re-encrypt them. This makes a huge saving in terms of resources. 80% of the world's traffic today is encrypted. For example, YouTube, Facebook, or any other traffic, it's already encrypted by the browser. We can also authenticate packets, and we are a zero trust network. The way we do routing, because we do from waypoint to waypoint, we introduce symmetry. We monitor flows. We can enable intelligent path selection. We can do load balancing and other fancy stuff. We can migrate session from one path to the other while keeping voice calls alive. We can also send the same packets over 2 different paths in the network and remove the redundant packets. For example, if you have a call which is very important and you want no degradation in the quality, you could send those packets over 2 paths, and delay jitter loss on any one path will not affect the flow. Of course, we have great visibility and analytics. You can watch all of these things happening in the conductor. You can see what paths your packets are taking, and you can decide accordingly on what to do. When compared to traditional IPsec tunnels or any other technology, if you look at it, what we really are doing is not adding a full IP header. So the IP header which gets added, a second IP header which gets added with IPsec, that's what we are removing. The advantage of doing that, it reduces bandwidth usage by about 30%, depending on the type of the packet. For a voice call, it would actually be 100% saving because you're not adding a full 76-byte header to an 80-byte packet. But the advantage of doing that is it improves congestion, it reduces congestion, and thereby the end applications, they perform better. It eliminates backhaul. You don't need to have hub and spoke or to backhaul packets to a single location. You can do multipath optimization. You can do session policing per service and improve scale. The branch routers today available can do maybe thousands of IPsec tunnels. But if you want to do millions of flows, then the only way to do it is without using tunnels. And that's what we do. This is a graph showing a comparison of what would happen when you use our technology over IPsec. That's what it looks like in the network. It would add a 30%, a 40% to 30% saving compared to any other technology available today. And overall, customers have told us that their end user experience improves by 7 times because now applications perform better over low throughput links as there is less congestion. If let's say you had multiple pathways between endpoints, today the only way to send packets and to fail over would be to have backup tunnels kept up all the time. Many of the providers we work with do not like this because it locks IP addresses from the LTE network. It uses data when not required, and to keep the tunnels up. And so the failovers are not, so it is very taxing operation and it requires a lot of tunnels in the network. The other option is when there is a degradation in quality in one of the links, you switch over to another path. And tunnels have to be established at runtime. When you do that at runtime, it takes a long time to set up these backup tunnels and to bring it up and to switch the flows. Usually, voice calls drop during that time. And that causes, of course, a lot of loss to the enterprise at the end. With our technology, because we do in-band signaling, as soon as there is a failure in one path, the flows will be switched over to another path. There's no setup time required because signaling is in-band. The router which receives the session from another pathway would start sending packets out immediately. It's a re-establishment is instantaneous. We have sub-second failovers in all cases, and we can go through any NATs or firewalls or any other devices in a network seamlessly. The other thing which makes network extremely complex is segmentation. When you want to go across different parts of an internet or have multiple networks, you have to do a lot of configuration in your network devices like firewalls, ACLs. You would have to have VRFs and map those VRFs, have encapsulations, tunnels, LSPs, route distribution, and so on. It's a very complex network. It takes time to establish. Any changes take a long time to percolate and require a long process. There are customers who have shown us ACLs which are like 3,000 lines long, and they are afraid to touch it because they might break something in the network because people have moved and they don't know what many of the ACLs stand for. It is a hugely complex network. It's not end-to-end, it's not directional, it's static, and it's a very flat topology. It's a very flat way of looking at the world. What we do is we enable segmentation using a data model that is hierarchical. So what we showed before, if you look at it from our point of view, that is you have a corporate and they have many different tenants like sales who has access to sales database, surveillance who has access to cameras, and so on. It's a very hierarchical network. It's very easy to configure based on names, and it's very easy to add, modify, and remove services. These policies are global, and the advantage is all of the routers understand this globally, and you can make a change into the network instantaneously at any point without affecting anything. The advantage of doing this is it's end-to-end, it's directional, it's very dynamic, and obviously it's hierarchical, like I showed. The other benefit we bring, and this is the last one before I go and talk about how to bring it all together. If you look at how networks are built today, you have networks, you trust everything in a walled garden, you trust everything within your network, and you put firewalls at the edges of your network to keep bad actors out. This is a very old way of doing things, as we know that most attacks occur from within the walled garden today. Also, there are a lot of ways to bypass firewalls and security appliances. It's not a perfect way of doing network security. The perimeter security model has not succeeded. In fact, with the data breaches and so on happening today, it's very evident that most firewalls are unable to protect against this kind of attacks. What we do is we follow a zero trust model. Every router is a layer 2 to layer 4 firewall. It authenticates packets hop by hop. So even if the firewall is bypassed, the router will realize that this session is not allowed or this policy is not allowed and will not forward packets in the wrong direction. We support adaptive encryption, which is basically the ability to detect and not re-encrypt flows, double encrypt flows. We are a completely distributed firewall in the sense every router is the firewall now. It's a deny by default model. So unless someone goes and configures a specific policy, there's no way to spoof or fool the router into forwarding packets. And routers, in our case, follow directionality. The classic example I give is if you have video cameras which are infected with viruses and they suddenly start sending video feeds to a single location, obviously they cause a DNS attack or a DDoS attack onto a DNS server. In our case, we can't stop video cameras from getting infected, but what we can do is not forward those packets to a single point. Any router in the path would realize that it has not seen a request for a video go out, and so it would not forward video packets back to a location. Directionality tells us many things like this, which makes it very powerful for us to avoid attacks. We also have Centric management, zero-touch deployments. You can shut routers out or appliances out, and it's zero-touch. It reaches out to our Yum servers, gets the software, gets the config, talks to the conductor, and boots itself up. We have open APIs in analytics. REST APIs are all available for you to develop apps or to give us commands or to integrate us or service chain us with any other applications. It's a distributive, non-disruptive deployment in the sense we don't need you to change your entire network to do this. We actually speak BGP, OSPF, ISIS, and other routing protocols with existing networks, and we learn routes from them, but we just do not forward based on that routes. We forward based on what we learn from them, plus what SLAs the service demands. And we are 100% service-based, software-based. We don't have any hardware. You can run us on any hardware, on any x86 hardware. You can also run us on any public cloud. And we have full application visibility and control. Because we are session-based, we keep detailed session records per flow, and we can tell you what is happening in the network and how to forward packets. What kind of deployments do we use, or what do people use us for? Mostly for SD-WAN, if you've heard about it, it's software-defined wide area networks, for virtual edges, for network as a service, for VPN replacements. We're also very popular and used for data center interconnect because we have bandwidth savings. You lower the amount of bandwidth you're sending between data centers. You can use us in hybrid clouds and a multi-cloud environment to connect your data centers with and spin up resources in Amazon or other public clouds as required. And of course, you can use us to build zero trust networks. One of the popular use cases we have is with unified communications providers or people who provide unified communication services, MSPs who provide these services to their end customers. I'll talk about a few examples. One of the customers we have is CMC Networks. They are a large service provider based in Africa. They're actually the largest service provider in Africa. They currently use us for software-based SD-WAN. They have a large network today, and they used to have a large network. And one of the challenges they had was because connectivity is poor in many of these locations, the end customers, they have SLAs with them. And when they don't meet these SLAs, they're forced to pay penalties. They required a solution which will work on their existing network, which already has encapsulations, not add any more encapsulations, and enable fast failovers. They currently use our solution. They are able to lower their cost by 40%. They have thousands of nodes which they can support. They can guarantee SLAs and not pay penalties. In fact, they estimate that just by reducing the amount of penalties or eliminating the amount of penalties they have to pay, they will recover the entire cost of the deployment. And of course, since we are an integrated box, we actually reduce the number of middle boxes they have to deploy. Another customer we have is Bard Materials. They are a construction firm a building manufacturer based in the Midwest. They have many sites which are remote, and they need to monitor video flows from these sites because it tells them the number of the trucks passing by, which tells them how much materials they're going to get. And they also have other requirements in the sense they want to failover between a wireless provider. They have a point-to-point wireless provider and DSL networks, which are not very great in terms of throughput. They want to have fast failovers and obviously advanced QoS. They use our solution today and they're able to increase the, because they don't drop this video feed which tells them the materials are coming, they estimate a saving of 1K per truck per day. They have lowered their TCO by almost 50% and they have great reliability now because of seamless switchovers. Another popular example of a unified communications provider using us is Revation Systems. They provide connectivity to roughly 300 hospitals in the US. One of the challenges they face is whenever there's a problem with the connection, the hospital or anybody else calls them up and says that, your service doesn't work well, and they do all this testing and troubleshooting, and they figure out, well, our service works fine. What doesn't work well is the connectivity you have in the middle, which they have no control over. They don't control the entire network. What they wanted is a solution by which they could extend the SLA from their data center to the customer prem. So what they do is today they use our solution and they place our solution at the customer edge, and they have multiple pathways. So if there's degradation in any pathway, they switch over the path to another provider or to another heterogeneous network, and they are able to guarantee SLAs to their end customers. They believe that by the bandwidth reduction alone has improved their efficiency, and they are able to also slash the time required to bring new customers up by because we can add, remove, and modify services dynamically. They have improved their SLAs and improved their uptime. Overall, before I go to questions or any discussions, I wanted to sum it up by saying these are the benefits the 128T solution brings. We are a Session Smart router. We obviously save time, money, resources, and we are lower cost. We save OpEx by using white boxes and so on. But we make overlays and tunnels unnecessary. We remove the encapsulations needed by IPsec and by other VPN technologies. The advantage of doing that obviously is it gives us superior throughput, better efficiency, reduction of costs, and of course, better end user performance. We make firewall encryption and load balancing native to the network, to the router itself, so we don't need any external devices or any external third-party units, which makes network complex and adds cost. The way you configure our network is by business logic. So it follows your business logic and it tells you your network does what your business really needs. And your business logic becomes the network language. For example, you could go and give marketing access to Salesforce, and all of marketing tenants in the network would get access to Salesforce and so on. So it follows business logic. And you don't have to worry about going through different private boundaries or public boundaries in networks because it's in-band signaling. You're able to transmit packets and go through different boundaries without having to have complex configurations in the network itself. I did a real quick run through of what we do and what 128 technology does. Overall, we have about, I think, 70 to 80 customers now. We are growing really fast. The deployments for us range from a couple of hundred sites per customer to a couple of thousand sites per customer. Some of the large customers we have thousands of sites, like their retail locations spread out all over the US or worldwide, and they have thousands of sites. Other popular use cases for us is oil and gas, where there is remote sites with low throughputs, or retail locations which are far out. We work very good in situations where there is lots of sites, there's large requirements, there's a huge demand on the network in terms of resources, because we bring bandwidth savings that helps us. And it really shines through when calls don't drop and we have unified communication providers using us, and they're able to show that any network issues will not degrade their call quality or their end user experience. In summary, that's what we bring to the table. I hope I answered or gave you a quick preview on what we do and what the network looks like for us. Any questions or comments?
And I'm looking to see here. It looks like not a lot of people have questions today, Ritesh. I think you covered everything quite well on what you guys do over there.
Well, if there's anything else, you can always reach out. I mean, you can see my email address is displayed there. You can always reach out to us with comments or questions, or if you want to, get the presentation, anything else. And I wanted to thank FreeSwitch for hosting me and for having me on the call today and giving us the opportunity to talk to you guys.
Yeah, no, it's good to see people out there doing some different things in the networking space. So I'm just trying to look here to see if anybody had any questions, and nobody's really asking any questions today. So now I do have a question for you here there though. Do you guys deploy these? I know you mentioned that you deployed your technology in companies that have hundreds or thousands of sites and everything. What about lower end? I don't want to say lower end companies, but smaller networks where they may not have as many remote locations. Say
Yeah, so we do have.
enterprise.
True. Your question is absolutely valid. Obviously the solution really shines through when there is lots of sites, because the scalability issues we fix, and you can't do it with any other technologies today. But having said that, we do have law offices, we have and so on, which have only 10 or 15 sites or even lower, and it works well in that cases also, because the bandwidth usage will be lower and performance will be better. But those deployments are less for us. I mean, in the sense, you could create tunnels and get by if you have 10 offices. But having said that, there's no reason for you to do that. You should have a simpler network and a much lower cost network. And we work well in those cases as well. That's true.
Cool. All right. Well, yeah, I don't think I've got any questions because you covered it quite well today.
Sounds good. Thank you.
Appreciate that. So before we let you get back to your day, is there anything else you want to get out there for everybody?
I just wanted to say that networking today is pretty complex. I mean, the number of routing protocols we have is high. Yeah, the number of RFCs is already crossed 8,000, I think. And and the increments in these RFPs are very small, in the sense the improvements are minor. If you want to see a really incremental change in your network or a big difference in your network, then you should choose a technology which changes things drastically, or whatever improves things drastically. And we do that by bringing a tunnel-free solution to networks today. So please reach out to us, and we are more than happy to talk to you guys.
All right, cool. Well, thank you very much, Ritesh, for joining us today. You guys go check him out, 123technology.com. And you see his email address on screen. So if you guys have questions and you think you can use this tech, drop him an email and he'll get you in touch with the right people over there. Thanks again, Ritesh, for joining us. All right, guys.
Thank you.
All right, guys. We're going to be back here on ClueCon Weekly next week. We've got some cool stuff planned. So don't miss that. Don't forget, like us on Facebook, follow us on Twitter. And if you're watching on YouTube, click that subscribe button right below the video. You'll click that. You'll subscribe to the channel. And then if you want to get the notifications, there's a little bell next to it. Click that also, and you'll get notifications next time we go live or the next time we post videos. We'll see you guys next week.
You've been watching ClueCon Weekly. Tune in every Wednesday at 12 p.m. Central. Keep up with the latest happenings by subscribing to our YouTube channel, follow us on Facebook and Twitter, or visit us at freeswitch.com.